Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
And welcome back to the third and final installment of the Reliability Matters podcast. We are here at the Global SMT booth here in sunny Southern California in the city of Anaheim at the IPC Apex Expo. I'm not in my normal studio, as you can clearly see. And a big shout out to my friend and colleague, Trevor Galbraith, for allowing us to interlope in his studio and broadcast this podcast from his studio here at the show. And also to the tech wonders over here, the tech goddesses, Summer and Jen. Oh, they're liking that. Oh, Jen's really eating up that comment. Yeah. Anyway, thank you both for pushing the right buttons at the right time and making us as best as we could be. So I appreciate all the work you're doing behind the scenes. My guest for this first quick segment is Kimberly Fagan. She's the marketing manager for PVA. Welcome, Kimberly. How are you?
Thank you for having me. I'm good.
And I understand that seconds before another person from your company was going to go on the air, they said, here, you do it, right?
Yes, that is correct.
You're a great sport.
Yes.
Thank you for...
I'll try to be.
Yes, I'm presuming you're going to be a great sport. Let's let our audience know, for those who don't, maybe for the 2 or 3 members of my audience who haven't heard of PVA before, tell me who PVA is, what types of products do you sell, and to what types of customers do you sell them to?
Sure. So PVA, we are precision valve and automation. We build dispensing and coating robots mostly, but we also build valves and meter mix systems. We kind of like to say we do it all. And in terms of the industries that we sell to, I would say defense, automotive. We're really trying to get in everything, anything that we can.
Anyone who needs coating.
Yes, exactly.
So it's funny, your company name came from like the tech behind the coating, valves, precision valves, which is all how you do coating, to, you're a coating equipment company.
Yep, absolutely. Our CEO started out building valves in his garage, and now we're a larger-than-life company. So
Larger than life. And you've been in this industry for how many years now?
It'll be 5 in October, so...
Okay.
Yep.
They may not have told you this when you entered the industry, but it is kind of a contract with the devil. It's a life sentence, right?
Oh,
like the mafia.
Yeah.
You only leave in a casket, right?
Yes.
So you're going to be here for decades, right? You might work for different companies, but you'll be in this industry for decades. Let's just go back a little bit to coating systems. Obviously, coating has been associated over the years with high reliability.
Yes.
Right? If you're building stuff that can't fail or people die, right? So if you're building space systems that you just can't go out and repair, or you're building avionics for aircraft or missile systems or medical stuff.
Yes, the stakes are very high.
Yeah, right. And the whole goal of conformal coating, of course, is to protect the assembly from the cold, cruel, harsh world that's out there.
Yes.
Do you find, you may not see it from your marketing role, but I'm just curious if you've heard of it, in the office water cooler conversations, that more and more commercial applications are starting to coat now, not just the stereotypical high rel stuff. Are you seeing kind of a more diversification of customers in various...
Yeah, absolutely. Fields? I mean, I think that at this point, the benefits of conformal coating more people are finding out about it, and it's a reliable application, and it can be used in a lot of different industries. And
I'm seeing with Internet of Things, with the electrification of stuff, and the fact that everything is now a connected device. They're making toothbrushes now that can log into your home Wi-Fi, and it has sensors in it, and it'll basically narc on little Johnny or Jamie on how long they brush their teeth for and how aggressive they,
I used to get my daughter one of those.
Right. Well, you'll learn some things, right?
Yeah.
But these are connected devices, and these connected devices are not what we would consider class 3 devices, so super high reliability devices. They're class 1 devices, which is the lowest expected level of reliability, consumer goods. But they're being put into harsh environments because where do we take electronics? We take them with us. Where do we go?
Everywhere.
We go into the snow. We go into the heat. We go into humid conditions, right? Yep. And I'm seeing more and more companies of class 1 devices, not high expected reliability, no one dies if they fail, having to coat their boards. Not because to prevent death and destruction, but just to keep the product working, right? So I am seeing a diversification of people who are doing coating. I personally am in the cleaning world. So we're right next to each other down the river. They clean, they coat, right? Or they should clean and then coat.
Yes.
So we're seeing more people cleaning to coat than ever before because of the fact that electronics is exploding. It's going everywhere now. Let's make a little left turn here. And it's I'm an old guy in this industry. I've been in this industry for 38 years. And I started when I was 3. Were experimentations with child labor.
Wow.
And it has always been, at least when I first got into this industry, a bunch of old guys. It's a very gentrified, male-dominated industry. And as what I like to refer to as the silver tsunami, all the gray hairs are retiring.
Yes.
Right?
Yeah.
And as they're retiring, there was a great exodus of people from our industry, and I didn't see a great influx of young talent coming into our industry, and it was quite concerning.
Right.
And I think our industry was concerned about it too. Now I'm seeing more and more young people come into the industry, and more women come into the industry, which is like, the industry will continue.
The women are here.
We have a good chance now of surviving. What was your experience coming into this industry? I think you said earlier you were a technical writer, so you have experience in tech stuff.
Yeah.
What was it like to come into the electronic assembly industry? What were your first perceptions of the industry?
It was, to be honest, it was an industry I didn't really know that much about. I didn't know it existed. When you're in college, you want to be...
Yeah, we're behind the curtain, right? Stuff just gets made.
Yeah, you don't think about
right.
how it is made, and it's been a very eye-opening experience for sure. And yes, it was a little intimidating, it being a boys' club, but I think, like you were saying earlier, once you're in the industry, you're in the industry. So the years and years of knowledge of people in this industry has really helped me personally as somebody who didn't have the background in it. I've just had so many great people to go to for advice and just teach me as much as I can before they retire.
Get them while they're still here.
Yeah, and I think it's exciting. It's an exciting time to be in the industry too. I think there are a lot of changes, and there are a lot of new, younger people coming in, and I'm excited to be part of that new wave.
So we talked before we went on camera. We talked about trade associations. You mentioned you were a member of SMTA.
Yes.
Service Now Technology Association. Have you attended their smaller expos or any of their small events?
We do a lot of their regional tabletop
shows,
events. Yeah.
And see if you've noticed this too. I find the value in those events not limited to the time you're standing at the table, booth duty. I find that maybe even a greater value is after hours, networking side. Have you been able to take advantage of that and kind of make connections?
Yeah, I think this industry, the face-to-face connections that you make can't be overstated. I think a lot of other industries are moving away from that, but just getting out here and talking to people, meeting them, it's so valuable, and it's been so
It's nice when you're working in a booth and people come up and go, Kimberly.
Yeah.
Now, it's confusing when they say that to me because I'm not Kimberly. But it's nice to be recognized. It's nice to be able to see people on, whether it's once a year or maybe a couple times a year on the show circuit or whatever, right?
And it's a huge industry, but it feels small. You end up seeing the same people, and it's got a family feel to it.
It definitely does. And what's surprising to a lot of people is if you look at how big the electronic industry is, trillions of dollars. Mm-hmm. It's all made by pretty much every company in this building.
Yeah.
Right? We're it.
Yeah.
Right? It's a small group of companies, relatively speaking, that make anything that has a battery or plugs into a wall. That's us.
Yep.
Right? So people say, what do you do for a living? And I try not to tell them. You're going to be in the same boat. If you try and explain conformal coding, you'll lose friends right away. Right? They'll just walk away. But I tell people, all the electronics you make, we make it work. And you're in the same boat. Mm-hmm. You don't make products that people then sell, you make products that people sell more reliable.
Yes.
Right?
Yes.
And then people stick around a little longer in a conversation. They don't leave you right away. They're not quite as bored. It's like, oh, that's kind of cool. Well, Kimberly, thank you so much for being a great sport, for jumping in. Tell your colleague that he owes you a big drink.
Yes.
In about an hour and a half.
Does.
Right? He owes you. And thanks for being my guest. And good luck in your career. And I'm now one of your network friends, and I'll look forward to seeing you at the next event.
Awesome. Hopefully it will be on camera next.
Hopefully we can do it. Yeah, we can do it off camera. Right.
Awesome.
I totally agree.
Thank you for having me.
Take care. Welcome back to this segment of the Reliability Matters podcast. My guest for this brief moment in time is Taylor Wagan. He's COO of CETEC ERP.
CETEC ERP.
Welcome, Taylor.
Thank you. Glad to be here.
Thanks for being volunteering, by the way, to be on the program. Tell me a little bit about CETEC ERP. I was not aware of your company before this moment, so bring me up to speed and my audience up to speed.
Okay. CETEC ERP is an ERP platform targeted at small and medium-sized companies. So many of the ERP systems that we know, we think of like SAP and Oracle, are targeted at extraordinarily large companies.
Yeah.
The Fortune 500. And that looks like an endless project with a budget of millions of dollars and armies of consultants. And quite frankly, that doesn't work for the majority of businesses in America and frankly in the world. So we are attempting to bring as many of those processes that come into the platform into the world of SMB. And we do that mostly by removing all the endless customizations and attempting to make that best practices standardized that can be configured and then delivered across the web with all the usual.
So instead of building something from the ground up for every customer, you've done research, you figured out what the typical packages would be.
That's right.
And you can customize it.
That's right.
You can do custom standardization kind of.
Correct. So you're going to have to change your workflows. For example, you're going to want to change, obviously your logo. What do your documents look like? What labels are you going to put out? And, this customer has a special label. Labels are always like one of the sneaky, terrible aspects of manufacturing and distribution. So we deal with that and let you kind of plug all those things into a framework that we can deliver and have set up from day one with what most people, most places want.
Let's back up a little bit, climb up the ladder, and get to a press box view. Most of my audience are in the electronic assembly space. Some are not. So most of my audience probably knows what an ERP system is. Some do not. So besides saying enterprise resource planning software,
it's a meaningless term.
Well, for me it's not, because I own a manufacturing company, but why should someone know that, right? If they don't need to. So, how would you best describe, if you were on an airplane and you were talking to someone and they said, tell me what you do, and I don't understand anything I don't understand the acronym. How do you describe what ERP systems do to maybe a civilian?
So if you start with the idea that we think of ourselves as a platform to run a business, and there are certain business processes that need a home in some sort of structure. So you're going to have at the core accounting. You have accounts and you have balances in those accounts, and so you think like QuickBooks or your ERP system or whatever it is for your accounting, and then that's going to tie into all these other areas. It kind of goes from there. You have we have inventory. Okay, so now an ERP system becomes the home for all of these pieces of data. And so you have inventory, you have orders, you have invoices, you're tracking, what work there is, you're tracking what does the BOM look like, how do we actually place a PO, and all of those very normal day-to-day business processes,
normal functions,
kind of live in this platform that is the ERP system. And one of our goals is to blur the lines a little bit and kind of extend into some of the other areas where, there's all these three-letter acronyms. MES and MRP and QMS and CRM. At some point, you're like, sure, and fries as well. And so we try to basically say most companies need a large part of those processes, and they have to integrate naturally because they are all part of one business. And so the more of those you can put in a single place and let somebody log in and then share the data around, the better off they are.
Excellent. Because the show is Reliability Matters, we're gonna force this into the subject of reliability, but I don't think we really have to do much forcing. How does the automation, I'm going to answer the question in my question, so I don't want to do that. How does an ERP system improve or impact reliability from your perspective?
Okay. The first one is the classic auditor game. If you think about like what does an ISO auditor do when they show up and they're here to increase your quality, increase your reliability and your throughput and all these things, it's like the first thing they want to know is show me the process for blank. And it can be a terrible process. That's the dirty secret. The auditor actually doesn't gauge.
As long as you are doing your terrible process, right,
and it's consistent,
right,
then they'll say, hey, you get a check mark.
Yeah, ISO doesn't mean you're building it right. It means you're building it consistently.
It's going to be
either
the same every time,
right or wrong.
That's like precision or accuracy.
Yeah,
yeah. So what happens with software is when you have that defined in the software, then all of a sudden you have created a reproducible and reliable way of doing something. So if we can make that process effective and efficient, then you're going to get repeatability kind of by definition there. So that increases both reliability, and then if the process is designed well, and that's where we put our effort, then you're also going to be increasing reliability and efficiency. So it's a twofer.
Is your software designed specifically for the EMS space, or are we one of the many shows you go to?
You are one of the many shows we go to.
Yeah. Okay.
So probably 20% of our customers are in EMS. And we like EMS because it's complicated. It has some unique challenges that help people understand why they might need a tool like ours. And if you go to...
So they get the aha moment a little sooner.
That's right.
Yeah.
They understand like, oh, I do need that. Mm-hmm. And that makes everything easier on our side. So
let's end on this. The big gorilla in the room, the gorilla's a little smaller now, but it's still a gorilla, is supply chain.
Yeah.
Right? I don't know if it's actually gotten better or if we've just gotten used to it and worked around it, but probably a little bit of both.
A little bit of both.
How does the use of an ERP system help or hinder or whatever description you want to put? How does it interface with supply chain, and maybe more specifically, how would an ERP system interface with the supply chain issues that we're seeing today?
Goodness, yes. There's a few. One of the major pieces of the ERP system is that MRP, material resource planning, where we're actually looking across all of your orders and all of your inventory, and then even what stock is going to be, expiring or going to be used, and we allocate it out as it's going to go, and then we can tell you at what dates and time you'll be short of what parts presented to you in a single report. So if we have all that data, we filter through, analyze all those things, and give you, here are the actionable things. And then you can even tie into tools and automate creating POs, linking to pricing and availability from your various vendors, so on and so forth. So I don't know how people live, honestly, without some sort of software tool there. It's going to be a lot of Excel work, or maybe an Abacus.
Every small company, we were a manufacturing company. We started off doing everything on Excel.
Yeah.
Well, we started doing everything on like checkered ledger sheets, and then we went to Excel.
Copy goes.
Yeah.
Sure.
And then we went to Excel, and then we went to some dorky automation system. It wasn't ERP. I don't even think it had an acronym. And then eventually, an MRP, and then
you kind of reinvent all the pieces.
It's a ladder. It's a ladder of discovery. You're already at the top of the ladder. You're just waiting for us to climb up close enough to even know what it is.
Yeah.
But certainly it does help. Well, how'd the show go? Good?
Yeah, it was good. It's honestly always nice to see customers and meet new people, and it was good.
Well, it's nice to see you. It's nice to meet you. Taylor Wagan, Chief Operating Officer for CETEC ERP. Thanks for being my guest and enlightening me and my audience on the description behind the acronym.
Amazing. Thanks.
You bet. And welcome back to this segment of the Reliability Matters podcast. For this quick segment, we're here with Neil Hubble. He's the president of Akrometrix. Where are you located?
We're out of Atlanta.
In hot Atlanta.
We started at Georgia Tech about 30 years ago, so we stayed home.
Well, very good. Well, thanks for being my guest. Thank you. I think your marketing people may have said, run over there, Neil. Do it now, right?
This did get set up quickly, yes.
You've been voluntold.
Yes.
So I'm glad they voluntold you, and I'm glad you're here. Your company manufactures metrology equipment for the microelectronics world. Help my audience and me. I'll blame my audience, but help me understand. Translate all that for me. What specifically do your products do, and how do they interface in our world of electronic assembly?
Sure. Yeah, we sell 3 thermal tools and about 5 room temperature tools that use 3 different optical metrologies to measure warpage or flatness, shape of really any type of product, or to measure the expansion or the strain of those type of products. So room temperature tools for flatness and just shape and general checking. Our larger industry is the thermal side, where we're mimicking what a reflow oven does or a reliability profile would do in like automotive, what have you, to see how those surfaces might change shape as they are heated.
Interesting. So many questions just popped in my head. So this show is going to be a little bit, maybe an hour or two. No,
Okay.
For the measurement for your non-thermal side, right? You're just measuring the effect maybe a thermal process had on something, or any process for that matter, weather related, humidity, whatever causes things to change shape.
Sure. Yeah.
Would that be on circuit boards, like maybe bare boards, or populated assembled boards, or components, or all of the above, or what do you
Definitely all of the above. We're all the way from raw materials and wafer all the way to final assemblies, together. More bare boards, more components, and those that are putting them together, the contract manufacturers, where the rubber meets the road in surface mount, that's usually where most of our interaction is.
And your description is for microelectronics. Is this specifically for microelectronics? And if so, what's the difference between how your products would be implemented from microelectronics to, standard large format electronics?
I mean, we do tend to get mostly into the surface mount space. That's where we live. Have we used it for anything and everything? We've measured refractory bricks and paper and, heat sinks and metal. Sure. Anything that needs to be flat, theoretically,
So your definition of microelectronics is surface mount, the small component, miniaturized components, as opposed to other electromechanical assemblies or something else.
Right, yeah. Semiconductor industry.
Right, yes, okay.
Yeah.
All right, just so we're on the same page. So you make equipment that measures that. What would be a common cause that would result in something warping or something coming out of tolerance? I think of maybe a board going through an oven and, it could bend and all, but are there some unusual causes, or are there poster child causes that cause people to even have to get equipment from you to check?
Sure. Well, first of all, they all move. It's just how much, right? People ask if something is flat. Nothing is flat to us in our world at our resolution.
You're looking too closely, right?
Yeah. I mean, sure, it's not going to be really flat, but is it flat enough, right? So the common driver is CTE mismatch. So coefficient of thermal expansion, how much something expands.
Yeah, something's moving this much, something's moving this much, and
if they're attached together,
someone loses.
Right, yeah. If you have on the package side, if you have a die and you have a redistribution layer, those have very different expansion characteristics. Someone loses, and a lot of that comes out in Z movement. So it plays a lot into, say, board design and copper balancing. We had a paper here at this show about how copper distribution and different material choices can affect the shape of local attach areas on a board.
Are there, in the board design world, they all go by design rules. Are there design rules that help minimize the TC differences and all that?
I think there's minimal, honestly. I mean, I think that's one of the challenges, right? Is process. Process to design.
Next generation of customers.
Right. Yeah. That communication between process and design. It's not always the first thing on the design list, but those process engineers, certainly, try to push on when they can in that area.
And is the use of your products, I'm assuming the use of your products is not once everything is established and procedures are made and protocols are followed. Is it more on within the design stage when to test out the design, or is it also used in production as every once in a while we test something? Or is it done when a shoot moment occurs?
All of the above. I mean, we started more failure analysis, more shoot moments, and we do contract testing, and a lot of those are that, shoot, I got a problem, come to us. What are more established customers? It's more part of their MPI. It's part of their process when they're doing early design, material choices, vendor choices. They're using that as part of their evaluation and setting in a product. And then a lot of them now are using it as purely a quality control. So a lot of your mobile packaging, they're doing lot sampling for everything they make just to make sure the process stays.
Nothing changed.
So it used to be failure analysis. Now you have 3 of ours.
Now it's QA.
Yeah, now it's QA. Now it's a lot of QA. So you might have, I have 3 systems lined up running 3 shifts, just doing lot sampling, doing QA, and doing volume. And our tools can test, multiple things at once, and it's all very fast, allowing for that.
So that's the segment of your business that tests after something's been made. It sounds like you also have the thermal side, which maybe allows you to force something to happen, almost like a halt test, where you're just bringing something to the point of where its tolerance ends. That's your thermal testing. That you're trying to bend stuff, and you're trying to
a lot of that quality is really on the thermal side. Yeah. So it's okay. What is this going to do when I put it in my oven?
Right.
So we're mimicking everything that's going to happen in a reflow oven, and seeing when my solder solidifies.
It's like a failure test. You're not pushing it past its limit.
No, we're not looking for failure.
We're simply mimicking a way where they don't actually have to build entire assemblies or whatever in order to see. We're simulating the environment that would otherwise may lead to a failure.
Yeah. And simulating is one of those words that sometimes people go in the wrong direction with our stuff, because we're physically, we like to say emulating. It reminds people that no, we're actually physically doing time and temperature.
That's true.
That's going to happen in production, because matching to like an FEA model is a common use of our products as well, right? They're going to check modeling against practical, and we would be the practical for that.
Right. And are your customers, do they fall into a specific group like Class 3, IPC Class 3 high reliability assemblers, or Class 1 consumer stuff, automotive stuff? I mean, are there certain industries and types of products that tend to care more about expansion and warping and things like that?
It is really very broad. It's definitely not just high reliability. Because you're thinking about some of the volume manufacturers who are just trying to push yield. And difference between 0.5% and 1%.
Cell phone manufacturers, right?
Yeah, huge in the cell phone side. So miniaturization is a big need for this. But also on the other end, some of the larger stuff, like trying to put down a very large BGA, for instance, onto a large board. That's a whole different challenge, that we're seeing. And that's one of the biggest trends we see is a lot of the big stuff in the AI side and all the data you got to collect now. Those are difficult things to assemble. Just the physical challenge of, a component that's, very large is quite a challenge for our customer base.
Yeah. One last question, and forgive the ignorance of this, but I can see your product is probably used obviously in the design phase and in the production phase, testing, etc. Is it ever used in the field phase? I can see, with electronics, with IoT in particular, with electronics frequently going out into harsh environments, whether it's in space or aerospace, where it's going into an unpressurized section of the aircraft and exposed to wild temperature swings, or it's going downhole in Houston, exposed to high thermals. Are there any testing protocols that you're aware of that will run a product for 6 months and then pull out of the field and test it to see if if expansion and contraction and warping occurs not just during the manufacturing process, but in the in-use climactic environment?
Yeah, I mean, honestly, not that much. No, I mean, we do, however,
things stay.
Yeah. I mean,
once they survive manufacturing,
But that reliability side is a factor for us. Because you might do like advanced thermal cycling and spend a lot of time trying to learn that.
Time machine.
Right, yeah. Trying to figure out how many failures you're going to have, how long it's going to take. What we would do is do that same thermal excursion a couple of times. And we've done studies, with people who have done the advanced thermal cycling work, and you can kind of map some of those failures to the warpage behavior. So, this corner has a lot of shape change from -40 to 100 C. Well, that's also the corner that starts failing first after a couple of months, in the cycling. So reliability testing in the subroom and the automotive is a pretty large area for us.
Interesting. And you had a good show?
Yeah, solid. Yeah.
Excellent. Well, Neil Hubble, President, Akrometrix, thank you so much for the impromptu interview and being a good sport and being my guest today.
I appreciate it, Mike. Thank you.
Good meeting you. Well, that is a wrap. Thank you for being part of our Reliability Matters family. Thanks for watching today's episode and the last few. We have been broadcasting from the IPC Apex Expo here in sunny Southern California. Thanks also to my friend and colleague, Trevor Galbraith, for allowing me to broadcast from his studio right here on the show floor. Thanks also to Summer and Jen for pushing the buttons at all the right times and making the magic behind the curtain occur. I'd also like to thank my friend and colleague Mike Butow of Circuit Assembly Magazine in the fact that he syndicates the show on the PCBchat.com website, and also Fred Schenkelberg from Ascendo Reliability, who also syndicates the show. You can find that at reliability.fm. If you're watching this podcast on the YouTube channel, the Reliability Matters YouTube channel, be sure and click the like, subscribe, and bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And if you're listening to this on your favorite podcast app, be sure and click the subscribe button so you can be notified when new episodes are released. That's it for now. I appreciate you watching or listening. Until I see you again, stay safe, stay happy, stay healthy, and perhaps most importantly, keep doing it right. And I will see you again very soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.